Welcome to week 8 in algebra. We are officially in our first week of October. I do want to make sure that you've got your math notebook out and you're ready to take good notes. These notes will help you this week as you go through your assignments for the week. Remember, you can always refer back to your notes, so these can be very helpful for you. I would like to take a moment to warm up and at the same time review what we did last week, where we focused on slope of lines. So we started really looking at and examining linear equations, and we know that all linear equations will have slope. They will have a slope that tells us the steepness of the line. So I do want to start with a warm-up that you are going to complete in your math notebook, where we're going to find the slope of a line that goes through the points 4, -3, and 2, 6. So you will need the slope formula to be able to find the slope. So if you do need to review that, you can do that. Remember, you've got the internet that is at your fingertips, so if you need to, even doing a quick Google search and saying slope formula, type in slope formula, and you're going to find that formula. And then I want you to apply that formula. Use these points to find the slope. So go ahead and click pause so that you can do this on your own in your math notebook. And then when you're ready to check your work with mine, go ahead and click play. All right, so we know slope tells us the steepness of our line. It tells us how steep our line is. And it's represented with the letter M. So M represents slope. And slope is rise over run. So it's the change, our vertical change over our horizontal change. So to find slope when given 2 points, we're going to use the slope formula. And since the numerator, the top of our fraction, always tells us the vertical change, what we're going to do is we're going to subtract our 2 y coordinates to find the number, that goes on the top, so that should be y sub 1. So we're going to subtract our 2 y coordinates. And then on the denominator, we're going to subtract our 2 x coordinates. And if you notice, I've got x2 and x1 and y2 and y1, and that's because we're dealing with 2 different points. So our first point, we would name our x the first x, and our y coordinate the first y coordinate. And when we talk about our second coordinate point, our second point, we would have our x2 and our y2. So then we're just going to plug in the values and find the slope. So when we first start by taking our second y coordinate, so our second y coordinate minus the first y coordinate, minus the first y coordinate. So we're going to have 6 minus -3. Yes, we do have a double negative because we're subtracting a negative number. And then we're going to do the same thing, but with our x coordinates. So we're going to take our second x coordinate. So the second x coordinate is 2. And we're going to subtract from that the first x coordinate minus the first x coordinate, which is 4. So then we just do the math. 6 plus 3 is 9. 2 minus 4 is -2. So we would have our slope would be equal to -9/2. We always want to keep our slope as a fraction so that we get that number on top telling us to move up or down, and then that number on the bottom telling us to move left or right. So this slope, it would give us a negative slope. And that's our warm-up. I am going to go on to the next slide, so if you do need more time on this slide to take better notes, go ahead and click pause. All right, so this week, you guys are going to start the week with reviewing slope and how to write the equation of lines in slope-intercept form, y equals mx plus b. That's how we write this the equation of a line in slope-intercept form. You're going to be creating some art with lines. So you're going to draw some straight lines to create a neat pattern or some art. And then you will also be telling me what the equation of your lines are that created that art. So time for you guys to be creative this week. And then we're going to move on and learn how we can write equations of the same line in different forms. So we know one format is slope-intercept form, y equals mx plus b. We can take that same equation and write it into standard form. Then we could take that same equation again and rearrange things and write it in point slope form. So we're just going to learn some more ways to write our equations. So let's jump right in. Slope-intercept form, we learned this last week where the equation is y equals mx plus b, where m represents your slope and b represents your y-intercept where it crosses the y-axis. M tells us how steep the line is with our slope. So other forms, though, we can write the same equation in several different forms. We can write it in slope-intercept form, we can write it in standard form, and we can write it in point slope form. So no need to copy this quite yet. You will see the slide again. So let's look at the standard form of a line. So the standard form of a line is just another way of writing the equation of a line, and it gives us all the same information as the slope-intercept form that we learned about last week. So what does it look like? Here it is. The slope-intercept form, or I'm sorry, the standard form is ax plus by equals c, where a, b, and c are going to be integers. They're going to be numbers. We're going to plug in numbers for a, b, and c. This is just the generic form, just like y equals mx plus b. So a, b, and c are all going to be integers. They're going to be numbers. And what's important in standard form is that it's very important to note this, that the a has to be greater than 0. The number that goes in for a has to be a positive number. So let's get some practice here. Really, when we write an equation in standard form, your x and y's are going to be on one side of the equation, and your constant, your whole number, is going to be on the other side of the equation. So let's practice. We've got an equation down below here written in slope-intercept form, y equals negative 3x plus 6. That's in slope-intercept form. Let's rewrite that equation in standard form. So again, all we need to do is get all of our x and y terms on one side of the equation and our constant, so the 6 would have to be on the other side of the equation all by itself. So really, we're trying to get 6 all alone here. That's our goal. We want to get 6 all alone here. That's like our C. So we need to move this negative 3x, we need to get that to go to the other side of the equation. So how can we move negative 3x to the other side of the equation? We want to use inverse operations. We want to do the opposite of what's being done to it to move it to the other side. So since it's being subtracted, I'm going to add 3x to both sides. That's how I can move it. Whatever I do to one side, I have to do to the other side. So now I've got 3x plus y, because I can't combine those. Those are unlike terms, equals 6. Remember that 6 just comes down? I just added 3x to both sides, so now I've got 3x plus y equals 6. Is that in standard notation? So we've got, remember, standard notation is ax plus by equals c, where a and b we're going to represent with numbers. So we've got 3x plus y equals 6. That is in standard notation. That is now in standard notation because we've got the variable terms on one side of the equation and the constant term on the other side. And if we look, it follows the rule that a has to be greater than 0. It has to be positive. My a is represented by 3. So here the a is the number being multiplied by x. 3 represents our a. 3 is being multiplied by x. It is greater than 0, so we are good to go. This equation is now in standard notation. 3x plus y equals 6. There's our standard notation. So I'm going to move on to the next slide, but if you need more time to take notes, go ahead and click pause. So standard form of a line. Again, here it is. This is what it looks like. AX plus BY equals C, where A and B will plug in numbers. So there will actually be numbers that go in when we have the actual form in standard notation. There will be a number for A and a number for B. So here's some examples just to kind of make sure we understand this. Some examples, 3x plus 4y equals -3. We've got our variable terms on one side of the equation and our constant on the other. And a has to always be greater than 3. So the number being multiplied by x has to be, greater than 0. And it is in this case, it's a 3. Over here, this is an equation in standard form. Our variables are on one side, our constants are on the other, and the number being multiplied by x is greater than 0. Examples that are not in standard form. So look here, even though we've got 3x and 4y, they're not on the same side of the equation, so that would not be in standard form. And then this example here, you've got x and y's on two different sides of your equation. This is actually in slope-intercept form. I'm going to go on to the next slide. All right, so I want you to go ahead now and rewrite this equation that is currently in slope-intercept form. I'd like you to take it and write it in standard form. So remember, to get it in standard form, all your variables have to be on one side and your constant has to be on the other. So what I always like to do is find my constant and then think, okay, I need to move this 2x to the other side. And how are you going to do that? So go ahead and click pause to show your work in your math notebook, and then click play and you can check your work with mine. All right, so I want to get my constant all on one side of the equation, and so to do that I need to move this 2x to the other side of the equation. So right now I've got a positive 2x, so to move that I'm going to subtract. I'm going to do the opposite. Whatever I do to one side, I've got to do to the other side. So now I'll have negative 2x plus y, those are not like terms, so I cannot combine them, equals 4. Am I done? Am I done? Well, let's see. I've got all my variables on one side, my constant on the other, check. Our a, b, and c, they're all integers, and then a is greater than 0. A must be positive. A is the number being multiplied by x. Well, I've got a -2 being multiplied by x, so I can't have that. So what do I do? Right now my equation is -2x plus y equals 4. Somehow I need to turn that -2 into a positive 2. So I'll show you a trick of how you can do that. We're going to take this entire equation and we're going to multiply that entire equation by a -1, because what that's going to do, I'm going to take it and I'm going to multiply by -1. What's a -1 times a -2? A negative times a negative always gives me a positive. So -1 times -2 gives me a positive 2x. So I fixed it. But remember, whatever I do to one term, I have to do to every term in my equation. So I'm also going to take -1 and multiply it by y, so it's going to just become a -y. And then I have to take -1 and multiply it by that final term. I have to multiply by every single term in the equation. So -1 times positive 4 is -4. And now my equation is properly written in standard form. So make sure that you always check to see if the a term is positive. Remember, the a term is the one being multiplied by your x. I'm going to go on to the next slide, so if you need to take more notes, go ahead and click pause so that you can finish up your notes. It's a wonderful thing about recordings is that we have that opportunity to click pause and rewind if needed. All right, so let's do one more. I've got an equation that's written in slope-intercept form, y equals 1/2 x plus 6. Let's move this so that it's in standard form. All of our variables on one side and the constants on the other. So I need to get really 6 all alone. So to get 6 all alone, I need to move that 1/2 x to the other side of my equation. So to do that, I'm going to subtract 1/2 x on each side, 1/2 x, When I do that, I get negative 1/2 x plus y equals 6. Is that in correct standard form? Look down here. A has to be positive. A has to be positive. Is A positive? It is not. Right now, A is not positive, and it's not greater than 0. So right now, it is less than 0. So we need to fix that. How can we do that? So to fix that, let's do what we did on the previous slide. So we have 1/2 x, negative 1/2 x, plus y equals 6. So we'll just take that whole equation and multiply it by negative 1. Negative 1 times negative 1/2, it's just going to change the sign. So it will be positive 1/2 x. Negative 1 times y is negative y. Negative 1 times 6, so we have to do it to every term, is negative 6. But are we done? So we made our A value is now positive, but do we have all integers? Do you guys remember what integers are? So integers are whole numbers. So when we write our equations in standard form, we have to have all whole numbers. And A has to be positive. So right now we don't have all whole numbers, but we can fix that. So let's, we got to turn 1/2. It needs to become a whole number. So in order to do that, the quickest way to do that is to just multiply the entire equation by its reciprocal of the fraction. So remember, reciprocal is just taking a fraction, and reciprocal is just flipping it upside down. So the reciprocal of 1/2 would be 2/1. So what we're going to do is we're going to multiply this entire equation by 2. So look what happens. When we multiply 1/2 times 2/1, we get 2/2, which is actually 1. So anytime we multiply a fraction by its reciprocal, we're always going to get 1. So 2 times 1/2 would give us 1x. Then we've got to multiply this times every term in the equation, just like when we got rid of the negative number. So 2 times negative y is going to be negative 2y. 2 times negative 6 would give us negative 12. It would give us negative 12. So we are now done. Now we have it in correct standard form. So it's very important that when you look to see if you've got something in standard form, you check, first of all, do you have all whole numbers? And then, is that number being multiplied by A, is that positive? Then you'll know if your equation is in correct standard notation. All right, we're also going to look at point slope form this week. This is what the equation looks like, where you've got y minus y1 equals m times x minus x1. So the only numbers that will go into this formula are for right here, our x1 and our y1. That will be an actual point. And then for our slope. So all these will actually be numbers. You're going to leave this y and this x alone. We're not going to substitute numbers in for that. I don't want to keep going with this because the recording is getting a little too long, but there's plenty of opportunity to learn about point slope in Edgenuity this week. So, that brings us to our key phrase. Let me write in that question for you really quick. So this recording focused primarily on the standard form of a line, which is A times X plus B times Y equals C, where A, B, and C represent numbers. So what is that rule that we learned about for A? So what does A have to be in order for it to be in correct standard form notation? If you need a review of what you need to do to complete the key phrase assignment, it's down at the bottom. Otherwise, I want you guys to have a wonderful week. And remember, I'm here for help. So if you need any help, let me know. You can email me. You can pop into the Thursday